July. I am Nawab Hussain Tangshong, lecturer economics. I am presently posted at Government Higher Secondary School, Turtuk. So in today's lecture, we will be doing elasticity, which is the concluding portion from your consumer behavior. So this particular topic will be subdivided into 4 subtopics. First is elasticity of demand, and then the second is elasticity along a linear demand curve, and the third one is factors determining elasticity of demand, and the final one is the relationship between elasticity and expenditure. So the first topic is elasticity of demand. So in our earlier lectures, you might have studied law of demand, which tells that there is an inverse relationship between price and quantity demanded. Now under elasticity, we will be studying how much will be the change. Again, in the last lectures, you have studied that demand is determined by certain variables. For example, if I write QD, QD is simply a function of P, which represents its own price. And then we have PR, which is your price of related goods, Y, your income, taste, and other variables. Over here, the P, which represents its own price, will cause a movement along demand curve. If this is your demand curve, say this is P, this is QD, then movement is from A to B. It will be caused by its own price. But apart from that, there are other determinants. For example, income. If an income increase, your demand shift. Similarly, price of related and your taste and preferences have the same kind of behavior. So elasticity will be defined as a degree of responsiveness of demand due to its determinants, which is price, price of related goods, income, taste, and preferences. Elasticity will be further studied or divided into first price elasticity of demand, and then you also have income elasticity of demand, and then you have cross price elasticity of demand, from numerical point of view, most of your portion will be limited to price elasticity of demand. Now what is this price elasticity of demand? It simply represents how much will be the change in demand due to change in its price. It is defined as ED. Again, ED is a pure number. We generally take its absolute value while calculating. So what does it represent? It is percentage change in QD. QD represents quantity demand due to percentage change in price. We can also measure the same using this formula, delta Q, delta P multiplied by P divided by Q, where delta Q represents change in your quantity demand, delta P change in your price, P represents your initial price, and Q represents your initial quantity. To know it in a detail, we will be taking an example. So this is the example. I have taken that initially your P note, which represents your initial price, is 10. At that point, your quantity demand is 20. You are at point A. After that, there has been a decline in price from P0 to P1, whereby your P1 is 5. Due to this decline in price, your quantity increased to 30, from 20 to 30. Now we use elasticity to calculate the intensity of this change, whereby your AD is simply delta Q divided by delta P multiplied by P into Q. Now here delta Q is 30 minus 20, which is your 10, and delta P is also P1 minus 50, which is 5 minus 10 minus 5. So I am putting the value 10 minus 5, P, which is your initial price, 10, and Q, which is your initial quantity, which is your 20. So here we get the value minus 1, whereby your minus represents the degree of slope. Since it's a demand curve, so it's negatively sloped. But we can use the absolute value to calculate the elasticity. So here we have 1 as an elasticity of demand. So in our example, we found the value 1. Now what does this represent? To understand that, we will study certain types of price elasticity of demand, whereby first we have perfectly inelastic demand. Over here, the absolute value of your elasticity is 0. Graphically, it tells that there will be no change in your quantity demand due to change in price, or your demand curve will be like this. Here, ED is equal to 0. That means no change in quantity, even your price change. The second is your unitary elastic demand curve. So here also you can write curve. So this simply means that your ED is equal to 1. In other words, it tells that your percentage change in quantity demand is equal to your percentage change in price. So here, if we look at the graph, it will be like this. Demand curve will be like this. It means the change is equal. When your price falls by 1%, your quantity will also fall by 1%. Now the third category is then perfectly elastic demand curve. Over here, your value ED will be equal to your infinite, which means very, very large. Now, graphically, what does it means is that if we put P and Q, then your elasticity will be infinite, or that means that there will be an infinite amount of change in your quantity demand to a very small change in your price. So as a whole, at a larger level, you can say, I will write here, that the value of ED will be between 0 and infinite. So its value will be between 0 to infinite. 0 means perfectly inelastic, 1 means you are unitary elastic, and infinite means 0 perfectly inelastic, and infinite is perfectly elastic. So in this range, we have inelastic demand curve between 0 and 1, while between 1 and infinite, you have elastic demand curve. So the next subtopic is elasticity along a linear demand curve. Now what is your linear demand curve? This one is your linear demand curve, which has a constant slope. If I write the equation for linear demand curve, then it is your Q, which is your quantity, is A minus BP. Now here we want to see what is the elasticity. So we know that elasticity of demand is delta Q divided by delta P into P divided by Q. Now what is your Q? Q is this. Now we need to find what is your delta Q divided by delta P, which is the first derivative of Q. Here we find that is minus B, or you can say delta Q by delta P, which is also the slope of this particular curve. It has a value minus B. Now on this curve we are calculating what will be the value of elasticity for different values of price and quantity. Now here first we are taking this particular point. Now what is this point? At this point your quantity demand is 0. So simply your price is AB. You can simply put the value of Q 0 in this particular equation. For example, if Q is equal to 0, then what is P? P is simply Q is 0, since Q is equal to A minus BP, which is equal to your A minus BP. This is A is equal to BP, or here P is your A divided by B, which is here. And similarly, we have this point. Here we are putting price is equal to 0. Again here if we put P is equal to 0, this entire thing will be 0, or Q will be equal to your A. So these are now we are also taking a midpoint. Now at midpoint the value of P on your y-axis will be half. So that is A divided by 2B. And similarly on x-axis this is the midpoint. If this is A, then this A half is your midpoint. Now here we are calculating elasticity at different point. First is elasticity at this point. It will be infinite. How it will be infinite? Because here I can use this. So ED is simply delta Q by delta P into P by Q. Now we know that delta Q by delta P is equal to B minus B. And what is the value of P? P is equal to A by B, A divided by B. And what is the value of your Q? Q is here 0. So we know that any number divided by 0 will be infinite. So that's why we have value infinite over here. Now similarly if we look over here, what is the value? Your P is here 0. And you have some value for Q. So whatever the value of Q is your A. So here simply again I am using the same equation. It is minus B, but the value of P is equal to 0. So it is 0, and the value of Q is equal to A. So it comes out to be 0 by A. So any number divided by 0 by any number is always 0. So we have 0 over here. Now the third is your midpoint. Now on this midpoint, this is the value of Q, and this is the value of Q, and this is the value of your P. So then ED over here is simply minus B multiplied by A divided by 2B divided by Q, which is A by 2. Again this one cancels, so as a whole the value is minus 1. Since I am taking absolute value, so it is equal to 1. Similarly, from this portion to this portion, your ED will be greater than 1, and over here your ED is less than 1. So in other words, at this portion, upper portion, your elasticity will be perfectly elastic. Here you have unitary elastic, and here you have perfectly inelastic. Now in this range you have inelastic demand, and over here you have an elastic demand curve. So we have other method also to calculate elasticity along the demand curve. Say this is your demand curve, this represents your price, and this is your quantity. I'm drawing a like segment A, B, and say this is your C. Now as per this, your elasticity is simply lower segment of curve divided by upper segment. Now for example, if I calculate elasticity over here, what is your lower segment? Lower segment is simply AB. And what is the value of upper segment? Upper segment is 0. It has no value, so it is your infinite. Again here, since it is equidistant, if you calculate here elasticity at C, then your ED is equal to lower segment, that is BC divided by AC. Since both are equal, so both have 1 value, and here it will be 1. Now at BQ, if I calculate elasticity, lower segment, what is your lower segment? Lower segment is 0, and upper segment is your AB, so it will be 0. So our next subtopic is factors determining elasticity of demand. Now over here, your elasticity will be determined by first your nature of good. Now in terms of nature of good, we have certain kinds of good. Some goods are luxury, some goods is necessity. By necessity means we have to consume it. So over here, whenever your good is necessity, you have inelastic demand, and whenever your good is luxury, you have an elastic demand. That means a certain change in price will cause a large degree of change in your quantity demand. Second determinant is availability of substitute. Now, any good that has substitute, it will be elastic. For example, if you take case of a brand of soap X. Now in the market we have different brands of soap, so whenever there is a change in price for a particular brand, we can easily shift to other brands because we have substitute. But say other example, which is necessity wheat. Even whenever there is a change in price of wheat, still there will be no significant change in demand. Now the third determinant is time horizon. By time horizon, we are talking about short run and long run. In short run, generally we don't have any substitute. So even for a particular product, whenever there is a change in price, we still consume. There won't be a significant change in demand. But in the long run, we will be looking for our other alternatives, so your demand will be elastic. And similarly, we have other determinant also. Usage of commodity or particular good. What is the usage of that particular good? Over here, if a particular good has a large number of usages, then it has an elastic demand, while a good which has only limited use, it will be an inelastic. So the last topic for today is relationship between elasticity and expenditure. Expenditure is the total amount of good that you are spending on a particular commodity. Now if I draw a demand curve, say this is your demand curve, QD, this is your P, and this is your Q. Say at point P, how much are you consuming? Suppose you are consuming Q1 of good, and for each good you have price P1, then your expenditure will be this entire area. Or in other words, if I say what is your total expenditure? Total expenditure is simply a multiple of price and quantity. Suppose price of a product is 10 rupees and I am demanding 20 units of that product, then the total expenditure is simply 200 rupees. Now I am using this table to understand what is the relationship between elasticity of demand and total expenditure. So far we know that we have certain kinds of elasticity of demand curve. we are taking three cases. This is your first case when your elasticity is greater than 1. Say this is P, this is Q, this is an elastic demand curve. And second, we are taking a case where elasticity is less than 1, or means it is fairly an inelastic demand curve. Inelastic demand curve. And the third one is a case where we have a unitary elastic demand curve, P and Q. Now suppose this is your initial expenditure, P naught, Q naught, this entire area. Over here I also draw the same, P naught, Q naught, and say P naught and Q naught. Now the first is your elastic demand curve. In this table, this portion represents your elastic demand curve. Here absolute value of ED is greater than 1. So this is this curve. Now what happens here? It tells whenever there is a fall in price, your total expenditure increases. Say from P naught, your price has increased. Now what does it means? You have an increase in total area. Similarly, if there is price rise, so from P1 we have P2, this is Q1. So whenever there is price rise, you have a sharp decline in this total area. Opposite is in the case of inelastic demand curve. Here, whenever you have a fall in your price, your total expenditure also decreases. That means this particular area is less than this particular area. And if there is a rise in price, P2, your area or total expenditure also increases. But in case of unitary demand curve, there is no change in total expenditure. Even if you increase your price or you decrease the price, the area of triangle, rectangle, or whatever you have new rectangle, the area will be similar. So in case of an elastic demand curve, whenever there is a fall in price, total expenditure increases, and whenever price increases, your total expenditure decreases. While in case of inelastic demand curve, whenever there is a price falls, your total expenditure decreases, or they move in opposite direction. While in the case of a unitary elastic demand curve, there will be no change in your total expenditure curve. Now we can also have a case of a constant elasticity demand curve. The classic case is rectangular hyperbola. So the last portion for today's class is about rectangular hyperbola. Now rectangular hyperbola is a curve which has a property that it has constant expenditure. If I presume the value y-axis represents your price and the value x represents your quantity, then it always have a constant value of total expenditure. So over here, what does it mean is simply that along rectangular hyperbola, you always have a constant value of expenditure. Say initially P naught and you have Q naught. Say this is 0, this is your x-axis, y-axis, and this is your x-axis. And suddenly this is your initial total expenditure, this total area. Area PO, A, QO, and O. O represents your origin. And now there is fall in price. Here it is Y2, so I can also use Y2, or simply I can put P1. And we have Q1. Then what represents is that it will have equal area, or you can say area P1, B, Q1, O will be, the two will be equal. Here in this graph you can see this particular area will be equal to this particular area, since you have xy is equal to c, which is always the same. So this is the case of rectangular hyperbola which has a constant total expenditure. So that is all for today's lecture. In tomorrow's lecture we will be doing chapter 3 from your microeconomics textbook, which is on producer behavior. That's all. Thukje Jule Salam.